Hello, in this video, we're going to introduce fetching data from external servers using Ajax. Um, so to be, so to begin, as you may recall, when you click on a link in a browser or when you submit a form from a browser, that browser sends what's called an HTTP request to a server. So that browser will send a request saying, "Hi, server, I would like you to give me some data, give me some information." Or maybe it sends a request if you're submitting a form where it says, "Hi, server, I'd like to update some data that's already there." So remember that we can send these requests whenever we click a hyperlink or whenever we submit a form. For example, if we had a form here that would let us, for example, search GitHub for a particular repo, that form would in theory send a request to GitHub saying, "Hi, GitHub, I'd like to see what these repositories are." And we have some code to do that. So if we look at our form that we've sort of put together, slide on that, right? We can specify in a form element itself where we want that request to go. We use that using what's called the action attribute for a form. So in this case, I can say I want my action to go to this URL in GitHub's, if it links to GitHub's RESTful API. We can use the method attribute to indicate what kind of a request we want to send. Most commonly, by default, we'd be sending a GET request. We're saying, "Hi, server, I'd like to get some information." It's also possible to send a POST request, where a POST request is supposed to represent sending, like, putting data on the server, saying, "Hi, server, I'd like to update your data. Don't get me new data. I want to sort of write to your data as it exists." Technically, either request can be used to manipulate the server. You're just sending a request to the server. It can do whatever it wants. In practice, most likely we'll be using GET requests to do this work. So what ends up happening is that when I submit a form and it sends a GET request, it'll send it to the action target, right, to the location we want to send it to api.github.com/search/repositories. And it'll, as a GET request, it will append the input elements as query parameters. So in this case, we have two inputs. I have one input that has a name of Q, which is for my search query, right? That's where the user is typing in some values. And then I have another input that's a hidden input, an input that's in the page, it's in the DOM, but it's sort of displayed none. The user can't see it, that has a name of sort and then a sort of built-in value of stars, so that we're always sorting by stars. So if I submit this form, I want to search for React, for example, when I go to Ajax to search for that. When I hit search, notice that my web page reloaded. It sends a request to a server. It's almost like I clicked on a hyperlink. That hyperlink took me to another location. And the location it took me to was that method, that action, right? api.github.com search repositories. And you can see here that the query parameters have the inputs have been attached as query parameters using, so my Q input, which I had named Q, is set to be React. And also the second input in there is sort, which is set to be stars. GitHub's API in particular says that if you send me a query parameter, or if you send me an argument called Q, I will use that as the search query. This is built into how GitHub's API works, right? It says I'm like any search query you want to send me needs to be called Q. It needs to have a parameter name of Q, not query, not search term, but Q. And then the sort tells us what to sort. Again, so these variables, like what those parameters are defined by the API what we're trying to talk to. Great. So when I send that request, it can go ahead and it sends, when I click to submit that form, it sends that request over to GitHub. And then I can get my data, right? See my data from GitHub. This data is coming in as a JSON object, right? This is JSON data. So you can see that it's an object that contains a number of keys in terms of how many counts responded to React, whether there were any complete results, and then an array of all the items. The first of which apparently is something from Free Code Camp. And then if you scroll down a little, here, let me see if I can make it a little smaller. And if we scroll down a little ways, eventually we can find the ones from Facebook's React, right? There's our actual React application we were searching for. Bigger so you can see everything. Okay. So yeah, that's our process. So again, if we submit the form, it goes to GitHub and it says, "Hi, GitHub, I want to see this information," and GitHub responds and says, "Great, here's the data that you were looking for at this particular URL. We've structured that URL so we get what we want." Of course, the challenge here is that we don't want to just like submit the form and then have the page navigate to GitHub. Is I want to be able to take this data, right, this JSON value that the server is responding to, and I want to be able to use that and integrate it into my application. I want to be able to show those results at the bottom here. I have some sort of just example like hard code results. You can see what it will look like when it's done. So I want to be able to see those results at the end, which means we need to make it so that our form doesn't go to another web page, but instead is able to send that request and get the data back without us leaving the page in the first place. So the process that we use to do that, to say, when I submit the form, send a request to a server to get some data, but don't actually leave the server, right? Don't actually send that request to have the browser navigate away. The process that just sends the request out, without navigating to that location, is called Ajax, which stands for Asynchronous JavaScript and XML. So Ajax is a sort of a code technique that lets us have our JavaScript code send an HTTP request instead of having the browser do it. So instead of having the browser send the request, like as if you submitted a form or sent a hyperlink where it both sends the request and navigates away, we're going to have JavaScript send that request without actually leaving the page, without ever actually navigating. Okay. Ajax was invented around in the sort of early mid-90s by Microsoft, or for Internet Explorer. That's sort of who formulated the structure and sort of put it all together. So again, we're using asynchronous JavaScript and XML. I'm going to point out what this word XML means for a second. So we've seen XML before when we've talked about React in general, right? XML is what of course stands for Extensible Markup Language, and it's basically a syntax for defining data and structuring data using tags and elements similar to HTML. You can really think of it as kind of like HTML, but you make your own tags. So for example, I could structure some data around a person where that person has a first name element, a last name element, a favorites element with music, with different music and food elements inside of it. Most likely, you'd probably do person, have them things like name attribute, and with different attributes put together. But structurally, we could organize and write our data in a tree of nodes similar to HTML. Of course, this ends up being really data intensive, right? In order just to keep track of the data I needed, which was Alice, Smith, Jazz, and Pizza, right? These 4 strings, I need a whole bunch of other text around it. This is a tree of data, which means if I want to navigate through it, I have to like traverse that tree, which is sort of not a fast and quick operation, sort of difficult to do. So XML, while a great way of standardizing and describing and sort of providing a schema around data, has sort of fallen out of favor in usage in terms of actually transmitting data over the internet. So instead, most sites and applications will use JSON as a way of transferring data. So JSON are JavaScript. It stands for JavaScript Object Notation. So it's the same way of writing objects that we would in JavaScript. So the only difference really is that JSON can't contain like functions or like functions really, but it can contain any kind of strings, numbers, booleans, etc. Everything. It's fine. So what we can do is we could take what would be sort of a really long XML tree and we could write the same kind of thing in JSON. This tends to be much faster. It's easier to write. Because it's written as a JavaScript object, it means that we can access elements directly, right? I can just go to breakfastmenu.food.price, food item 1.price and get that price directly. I don't have to navigate down the tree. It's faster to parse. It's faster to navigate. It's sort of smaller to send. It tends to be a better transmission medium. So when we're really talking about communicating with a server, we're almost always actually communicating in JSON. We're not using XML. We're using JSON to do that work. So really, it'd probably be more proper if we called Ajax AJAJ, where it's asynchronous JavaScript and JSON, but that really didn't stick, so we continue to call it Ajax. All right, so that's the sort of idea of where we're going. So how do we do this? What we want to make sure to happen then is that when we submit our form, right, when we submit our thing, we want to make sure that let's add our handler in here, right? We want to make it so that when my form gets submitted, so we'll add it on submit real fast, handle submits. Right, we want to make it so that when my form gets submitted, we don't do the normal thing of going to another web page, right? We're going to prevent our default, and now we want to be able to have some way of sending this request ourselves, right? So we're going to do this work where we send something with our form data, we send that request. We'll send that HTTP request, we're going to do it right here from inside this function. All right, I'll put a console log so you can see it happens. Sending a request. And just to demonstrate that it's all hooking together, right? So if I refresh and I search for React, when I hit search, you'll notice that, again, it's sending the request and all comes together. I'm going to make my default value actually be React so that I don't have to retype it in every single time we refresh the page. Okay. All right, cool. So in order to send an Ajax request, we're going to use a set of functions built into the browser. These have been built into browsers since like Internet Explorer like 3 or something, like an old version of Internet Explorer. And we're going to use an object called an XML HTTP request, which sends an HTTP request and asks for XML data back. This is what it looks like. I got a picture of it just so you sort of see what this is. This was developed by Microsoft in the early 90s. It's messy, it's complicated, it's incredibly verbose, and it's really kind of a pain in the ass to read, and it looks deeply confusing. Though, look, there's functions and if statements and variables. Like, these are things that you're used to seeing. So that's really verbose, it's overly complicated. We don't use that in modern data. So instead, while XML HTTP requests are used kind of underneath the hood, we've got better interfaces, better functions that'll achieve the same result. So I want to point out that such a thing exists so that if you see errors or have issues around XML HTTP requests, that just means Ajax. We're sending a request to somebody. So the way that we send Ajax requests in kind of modern, current web programming is we use a method called fetch. And fetch looks a lot nicer. It's a method that's, again, built into the browser. It's built into the DOM APIs. And we call fetch, and we just pass in a string of what URL we want to fetch from. So the way that we would write this out is if I want to send a request, I would simply say I want to fetch from some URL. And let's see, we'll find the URL is going to be the same place my forms action would go. So we'll start with that. And I'm going to add the React query built into it here. Actually, here we can just make it plus type. What's the name of my state variable? Query input. Cool. So that's my URL that I want to fetch from. Okay, and that's how fetch works, right? We just say fetch from a URL, and that will send a request over to the server to say, get me the data from that URL. Now I want to note that fetch is not supported by all browsers. It's supported by pretty much everybody, right? If we go to can I use to say what browsers support fetch, all current browsers, except for Internet Explorer, because Internet Explorer is not used anymore, pretty much support fetch. Opera Mini doesn't, but everyone will work with fetch. It's generally not a problem. That said, there are older browsers, older versions of Edge, older versions of Safari. Anybody who happens to be on, Internet Explorer, which again is still like, half a percentage, so 1 out of every 200 people still use Internet Explorer 11. If we try to just call fetch, those browsers won't support this function because they don't have a fetch function built in. So what we tend to do instead is to also include what's called a polyfill. So a polyfill is basically going to be an external library, sort of a chunk of code that we're going to grab from somewhere else, that we're going to load from a library, similar to the way we loaded Bootstrap scripts as a library, that will provide that functionality to that browser. So basically the script will say, hey, browser, do you have a fetch method? And if you don't have one already, well, here's the definition for one built on top of XML HTTP request. So that way we won't have to worry about what browsers exist. All browsers will be able to fetch this data and make that work. Okay. Polyfills are something that do exist for a number of different modern browser features. They're a way of providing older browsers with sort of newer advanced functionality. As browsers become, move on, as technologies become new, they stop becoming less important because, again, there's less people that they support. But if we really want to hit all browsers, we want to make sure we're thinking about when we're using these kinds of new features. And again, fetch is from like 2011, right? It's about 10 years old, but still new in that sense. We want to be thinking about when those pieces hook together. Okay, so in order to include fetch, there's a polyfill where it's basically a script library. We can be able to include it. The what function we're going to use in a React application in order to make sure that fetching can work in Node is we're going to fetch what's called the WhatWG fetch library. So this stands for the WhatWG is not like saying what WG, it's the World Hypertext Association of Technologies working group. Actually, I'm not totally sure what this one is, but it's a working group. So basically it's a group that sort of defines this fetch standard. So we can install this library and then import it, and that'll make sure, and that basically includes the polyfill into our script, into our React scripting application that'll make everything work. So we're going to go ahead and install WhatWG fetch really quickly. I don't think I can't use it more. So we're going to install this real quickly, right? We can go to our terminal. We can go ahead and install WhatWG fetch. Sorry. npm install WhatWG fetch. And again, it's just like installing any other external library. Oh my gosh, it'd really help if I typed correctly. Quick package, quick installs very, very quickly. And then in our index.js file, right, sort of in our initial file that we're using to load our application, we're going to go ahead and just import it. We're not going to import it as anything. We're not giving the name, but this will basically load fetch into global namespace. so that whenever we want to call fetch anywhere else in our application, the browser now knows what we're talking about, has now supplied that function. It's now polyfilled that in to make it available. Okay, and with that, we can now call fetch, and everything can work the way we want. So we're going to call fetch, and we can do that work. So we're going to call the fetch function on a URL. I'm going to console log the URL just so we know that we know what we're fetching from. I have this. We'll do sending request to the URL, so we know where it's going to. We're going to call fetch. Fetch is a function, so we know it's going to return a result. So let's go ahead and we'll get that result to see what we get back. Console log it out to see what we get. All right, we refresh our page. So everything's loaded, we're ready to go. We've got our form, we're going to hit search. When we hit search, it sends a request to api.github.com search repositories query React. If I click on this and open it up, you can see that it's opening up the results that I'm looking for. So I know it's sending a request to the right place. And I got back my result, and my result says promise pending. That's the result coming from line 28 there. We expand that out a little bit, and it's okay. It's got a bunch of prototyping stuff. All right, something's going on here. So what we got back was a promise. What's a promise? All right, so here's the deal. Ajax requests are asynchronous. That's the A in Ajax. That's actually the most important part of this. An asynchronous operation is going to be an operation. It's going to be code that happens simultaneously with everything else. So it's not happening kind of in synchronous in order with the other lines of code you write. It's happening kind of asynchronously at the same time as this other code. So really the way you can think about it is that when you send a request, it's not actually, your code isn't actually waiting for the response to get back to you. What ends up happening is that, for example, if I send a request, I say I'm about to send this, right? I run this line of code. I then call fetch. That sends my request for some data, but then the browser, the JavaScript doesn't wait for that data to come back. It just keeps going. It says, nope, next thing's going to happen is I'm going to just say I sent the request, and like that request has gone off into the space, and we're just going to keep moving. The metaphor I usually use to think about this is if you are working on your homework, for example, right, and you have a question, you might send a question to your professor, ask a question to your instructor, and say, hi, I have a question. And you send that question in, and then you don't just sit and freeze and not do anything waiting for a response. You either keep working, right, keep trying something, you go try something else, you'll get some coffee, right, you go do other things. So you're not just stuck waiting for that response to come back. Because as I send a request to a server, that server might take time to handle that request, respond to it, send it back, right? It might take a couple of seconds, even a couple of minutes, like depending on how much complex that process is. With the professor, it might take hours to get stuff back. So the idea is that when we fetch, that isn't actually getting the data, that's sending a request. It's like sending out an email to saying, hey, other server, hey, professor, I would like some information. Right? That's what I want to get. So at some point in the future, way later, right, whenever the server gets around to responding, that's when our data actually comes back. So because Ajax is asynchronous, we have to wait for that data to show up. And so because we have to wait, what the fetch function does, right, in response to sending out a request, is we get back what's called a promise. The best metaphor for thinking about what a promise is like a buzzer at a restaurant. So you know that if you go to a restaurant, at least in the US and the Western culture, if you go to a restaurant, if you go up to a restaurant and say like, hi, like a table, and they say, okay, there's no tables yet, right? We need to get it ready for you. And they hand you these little bricks, these little buzzers, that's going to be like, you can hold on to this and we will buzz it. We'll make it flash when your table is ready, right? When we have your data for you, we're going to make this thing flash. So a promise is basically that buzzer. When we call fetch, it doesn't actually give us a table yet. It gives us a little buzzer to tell us when our table or when our data is ready. So this thing that we got back isn't actually the result, is actually a promise. And I'm just going to call fetch promise because that's what it is. It's our fetch promise. So we got back our brick, right? Our little buzzer. So promises is a particular data type. It's a kind of object. It's a particular kind of class. And that object has a number of methods and functionality we can do, right? So we have this buzzer. There's now stuff that we can do on that buzzer. In particular, now that we have this buzzer, right, our fetch promise, we can call methods on it, just like we call methods on any other object, right? We got a buzzer. We don't have the data, but we got the buzzer. In particular, the most common function we're going to call on that buzzer is a function called then. And the then function takes as an argument a callback, a function that says, what do you want to do when the buzzer goes off? So you can almost think of this a little bit like saying, it's almost like add event listener for buzzer goes off type events, right? And then there's some function callback. Like that's almost what we're doing. We're saying, what do we want to do when the buzzer goes off? When my data is ready, we want to be able to then do something. So we can then write ourselves our function to do that, right? I'm not going to use arrow functions at the moment just because I want to indicate, be very clear this is a function. But we can have a function that's going to return, get some response back. And then when that function goes off, it's out, right? Buzzer buzzed. And we can log out then what my response is, what response I got back. So fetches give us, the fetch function gives us a buzzer back, and then we have to take that buzzer and say, okay, I'm holding the buzzer. What do I want to do with it, right? How do I want to respond to it when it goes off? What do I want to do next? Okay. More commonly, you'll see this again using, we can write this out with like an actual callback function, but more commonly, we'll actually write this all and string it together, right? So you'll say fetch a URL, then execute some function with the response, which reads almost like English. That's why they call this thing then, not add response listener, right? It's just a then because it's saying fetch the work, then do something else. Awesome. Cool. So we can do that work. We're gonna refresh our page. I'm gonna submit my form for React. Notice it sends a request, and then I get my promise back, and then sometime here, let me see if I can do it faster so you can see it. Watch down here for a moment. Do you see how there was, I mean, it's going quicker than actually here. Let me try, let's search for Bootstrap. Do you see how there's a beat? There's like a wait before that response, before that, after the buzzer buzz, before that response sort of came back? That's because it took a second, right? We had to send a request to GitHub, and then it took a second for GitHub to respond and let us know, hey, your data is ready. Here's what you got back. All right, cool. So here's my response. It's an object, and because we're sort of specialized response type object, and it has a number of different pieces in it. A body, a headers, an OK, a status, a type, a URL, right? We can see what URL we sent stuff to. Notice it sent it to queries Bootstrap, I spelled Bootstrap incorrectly, right? So you can see that it tells us where it sent that query to, as a lot of other details that we got back. Okay, so this response that we got back is not the data itself. What we actually got back is an HTTP response, right? Because that's what I said. I said, hey, server, I sent an HTTP request to the server, so I got back a response itself. Think of it like an envelope, right? We got back a big envelope containing all the data that we looked for. Our envelope has two main parts that we need to think about. So our envelope contains a header that has meta information about the response. And that's what we're seeing here, right? The thing like the return address, right? Where did the envelope come from? The status, how is the, what's the status of the request? Is it a good envelope or a bad envelope? Right? So that's the data that we're getting back from this envelope. And we can actually see that information from it, right? I can just access it directly. Like, for example, if I want to access the status of my response, because response is object, I can just say, go get the responses, dot status. And then, again, when I search for React, I get my status of 200. What's the status of 200? Glad you asked. So this is what's called an HTTP response code, and this is the thing that you'll often get back from servers. You are familiar with HTTP response codes. You've seen them before. The most common response code that you've seen is a 404. A 404 is a code that indicates that the server, the resource, the thing you were trying to access or get was not found. And you see this when you get page not found errors, right? These are 404 errors. And the reason we're using the word 404 is because that's kind of the code built into the HTTP spec that lets us communicate about the status of these requests. So 404 means that something is not found. 200 means that a response was okay, everything was good. That's kind of the standard. Yep, you're fine. Life is good. Keep going. You might get 403 responses fairly commonly. Those are forbidden responses. That usually means you didn't include a password or you don't have access to something. It's not the data isn't there, it's just that you're not allowed to get to it. API keys is incorrect. You might often get 403 errors. And then sometimes you might get 500 level errors, which are internal server errors. So that means that it wasn't that the response wasn't there. It's that I said, hey, server, I'd like some data. And the server said, nope, I'm having problems. I cannot respond to your request. There's a whole bunch of these different error codes. So, and of course, I've got cat pictures to go along with all of them. In general, the 200s are everything is fine with some variation on what we mean by fine. 300s are for things like move permanently. Like I sent a request somewhere else and they said, oh no, your request was good, but you actually need to be going to this other place instead. And I'm going to redirect you there, right? So it means that there was some like everything was okay, but like you just need to sort of update your response and make sure you're more up to date. 300s are used in that kind of way. Like there's something else going on that like there's not a problem, but you need to figure out what's happening. 400s are bad requests. Those are where things are unauthorized, right? Those are, again, sort of when you are required to do, when you've messed up, right? You've sent a request for something that you're not supposed to, you're not allowed to, or to the wrong way. If you get a 400 error back, it's probably an error on your end. You probably sent a bad request. You did something inappropriate. On the other hand, right, maybe your response to your URI was too long. On the other hand, a 500 error, where do they go? 500 errors are errors on the server's end, right? So it's not that you did something wrong, something's wrong on their end. Stuff like internal server error, bad gateway, service unavailable, right? There's something going on their end. You did everything okay. It's that the server is having issues. So that usually means you like have to sit and wait or make sure you're actually talking to the right server. Okay. So again, there's lots of these different error codes. You don't have to know all of them, but it's often kind of fun just like knowing what codes there are, what they use, and what they mean when you get through. But again, roughly 100s mean what are 100s, right? 100s are sort of our just overall status stuff, right? Just seeing that everything's okay. 200 means, yep, you're good. 300 means 0 good. Maybe update things to make it better in the future. 400 means you screwed up. 500 means that there's something they screwed up. All right. Anyway, response codes. That's fun. So once we get that response code, right, we go to our 200. We then, of course, want to get to the actual data itself. So let's go back to our response. Search for React. So here's our response. Notice that our response includes things like the status code, and we could do things, we could put like an if statement, right? If response.status is not 200, there was a problem, and react to it. We want to get the actual data itself. The data is found inside the body. So again, if we think about this as like an envelope, right? The header is like the metadata, the stuff on the front of the envelope. The body is the stuff inside of the envelope. That's the data that I'm actually looking for. All right, so here's my body. Notice it's just showing me 3 dots for the body. So I can click on this, and it tells me the body is a readable stream. So a stream is a sequence of data of some kind. Generally, zeros and ones is the most basic kinds of binary streams. So it's kind of the idea is that what happens is that when we send this request for this data, right, from GitHub, GitHub sends us a response in envelope, and in that envelope is all the data, but it's all a bunch of zeros and ones. It's almost like they sent it all back to us as confetti. It's all the data's there. It's just a jumble. It's a mess, and we can't actually do anything with it. So what we need to do is we need to take this stream and this data, this sort of confetti, and we need to convert it into a format that we can actually read and work with. That's called encoding the data, right? We're going to take that data and turn it into actual JSON content. We're going to basically say, put all the zeros and ones into place. The function that we can use to do that, right? So we can take our response, we can use our response, and we can call a function on it called JSON, the JSON method. The JSON method, if called on HTTP response, will basically opens up the envelope, takes out all the data, and will encode it structured into a JavaScript object for us to use, right? So this should be, right, the result of this guy. We call response.json. So I'm going to console log that result. We're going to see what we get. So here we go. Search for React. We got our data. We then say, let's encode the data. Let's get everything out of the envelope. And what we get back is another promise. We got back another buzzer. That's because encoding this data, right, taking out all that confetti and like hooking it all together takes time. Just like sending a request to something takes time. So the browser does it asynchronously. It doesn't sit there and just freeze and then make your page unresponsive, make nothing work while it's trying to get all the data encoded. It'll start encoding the data asynchronously, kind of in the background, then let you know, gives you a buzzer and says, hey, I'll buzz you when we're all done. So we got a buzzer, right? So this is now our encode promise, what we got back, right? Another buzzer, another promise. Of course, now that we've got another buzzer here, we can call .then on that, say what I want to do, and that buzzer goes off. And this one will actually give us the data. Right. Oop. Once that buzzer goes off, that second buzzer goes off, then we'll actually get the data that we can now do something with. So here we go. We're gonna search for React, right? We get our first buzzer, right? We get our first buzzer saying, hey, got your request. I'll let you know when your data is ready. The buzzer goes off. They hand us our envelope, says, hey, here's the data you asked for. We say, great, that's awesome. I take the envelope. I'm like, well, I better open it up and start piecing it together. They say, great, here's another buzzer, and I'll let you know when we're done piecing it all together. And then once that I've done piecing it all together, the argument, right, the result that we got back when this was already, the data, is now available for us to use, and I can now console log it out in order to see, there's my results, and there's sort of the first 30 items I got back of all my React stuff. The second one, which we remember, was the URL. Oh gosh, where'd it go? Right, there's React from Facebook. All right. All right, awesome. There's our process. So I know it's really wordy. It's a lot of functions, like multiple buzzers going on, waiting for us to get our data response back. Okay. Luckily, we can make this work a little bit cleaner. So here's the trick, is that remember we got this first buzzer, right? Our fetch promise here. When we call .then on it, right? I said fetch promise and I got a .then, right? I said when this buzzer goes off, do something. Well, .then is a method. It's a function, which means that it can return a result, right? This could be my first buzzer results. Because that's, again, what happens. That's what we're going to return when that buzzer gets sort of put together. Now, the way the .then function is built, the way it is structured, right, the way that we can have a result from this promise, I'm just going to go ahead and we'll call it first. That's fine. What can happen is that if your callback, so remember we have this callback, right? That's our thing to say, this is what to do when my promise is finished, right? When my buzzer goes off. If that instruction returns, right? If it returns a promise, then what ends up happening is that this function, right, returns a promise, returns a buzzer, and that buzzer is basically used to update the previous buzzer. There's some structuring that's happening, some state management that's going on underneath the hoods provided by the browser that makes these things hook together. So basically, it's almost what's set up to happen is that I call fetch, and they say, great, your table will be ready. Here's your fetch buzzer. And I say, okay, great. When my fetch buzzer goes off, do some work, and then whatever buzzer, if you have to hand me another buzzer, like to encode the data, don't actually give me a brand new buzzer, just replace my previous buzzer with a new one. Let's just buzz the thing a second time. So basically what that means is I can take this second buzzer and I can return it. Right? Cut that stuff out from that. So I can return my encode promise, right? Say, here's the buzzer you were about to get back. And that'll take this promise, this buzzer, and it will update my first buzzer result so that now my first buzzer is also waiting for the second time for it to go off. So basically it ends up hooking these things together. So this buzzer says, wait for the first thing to go off, then wait for the second thing to go off as well. So because this is now the updated buzzer, right? Effectively, that's what we're getting. We're getting my updated buzzer, and this is going to be now saying return to update the buzzer, the original buzzer. Now that I've got my updated buzzer, I can take my updated buzzer and I can say, after you've updated your buzzer, then again, after you remember the second buzzer, the updated buzzer, my encode buzzer is going to go off when I've finished hooking together the data. Once I've got that together, I can say now log out my data once my updated buzzer is finished. So this first says take my first buzzer. When it goes off, do some work and then update that first buzzer. Now, when that updated buzzer goes off, then do something with your data. And that's our structure here. So we sort of reorganized our code a little bit, and then I moved this encode promise.then outside of my sort of original fetch promise, so that now I have this sequence where I can say, fetch some data and then update your buzzer, take your updated buzzer, and then log out the data. And again, this is all going to still work, right? I'm still console logging out my data for me to be able to see. All right, cool. And that's our structure here. Again, if you use the collapsing structure and kind of ignore the fact that there's stuff happening when a function is done, really we want to think about fetch some data. Then when that's done, update the buzzer, waiting for anything else to get finished. When that updated buzzer goes off, then we've got some data and that hooks together. All right. Of course, this updated buzzer, right, the one that we're using right here, updated buzzer, that is equal to this whole fetch promise thing, right? So I can actually say, let's cut out that fetch promise and let's replace updated buzzer with that thing in the first place. And then what we end up getting, right, is we're going to say fetch my promise and then do some work and then do some more work. And we can sort of reorganize this onto, reorganize the code a little bit. Let's, I'm going to sort of put this onto its own line. I'm going to take these pieces and indent them a tad. I'm going to get rid of this step, keep my encoding there. And that gives me my overall structure. And of course, fetch promise is really just fetch URL. So I could actually even step away from that and just replace my fetch promise. Let's go ahead and delete it with my fetch URL. And again, this all continues to work. There's my data. So altogether, right, I know that's a long explanation about how fetching and promises work, but in the end, the way that we write fetches code, the way that we send Ajax requests and get data from another server, is we fetch from a URL, and then based on that data, we are then going to take our data, we're going to encode it, update our buzzer with that, and then go ahead and log out our data, what we want to do in the first place. Often you'll even see this condensed, so this in just becomes return that JSON initially, and then you get your magic 5 lines of code, fetch data, then convert it to JSON, then do something with the data. And that reads, again, almost like English, sequence of steps we can do in order to be able to make this come together. And that's how we can fetch data. That's how we can grab access information. That's the basic idea. All right. So a couple of other details to mention along with fetching data. But anyways, this is the boilerplate code. If you need to fetch data, that's what you start with. And that will generally get you where you need to go most of the way. Okay. A couple other things that we need to note. In particular, we can catch errors that occur. So it's possible that when I send a request, I might send a request to a bad URL, right? I might have a problem there and that might cause a problem. I might send some data and get an error back, right? It's possible that the server actually just like rejects my response or has some other error that doesn't give me a code, like a 404 code, actually says like, here's a problem, I'm just like crashing entirely. So the promises, right? Because remember, each of these .then returns an updated buzzer. Any buzzer, whether it's the original buzzer or one of the updated buzzers, we can also call .catch on it to specify what should we do when an error occurs. This is how we catch errors. Catching errors is a term that comes out of programming. Sort of the way I always think about it is like when a program hits an error, it throws its hands up in the air, but like, oh my gosh, I can't believe I hit an error. And your job is to then catch all the stuff that's throwing, the papers that's throwing up in the air in order to catch them and sort of manage that error. So we can catch errors by, again, defining a catch function, similar to how we call it .then, say what function we want to run if an error occurs. For example, we can console log it, we can show it on the screen, we can do something to let the user know there was a problem or that we let us as developers know so we can go fix that. You can put a .catch after any sequences of .then. Like if this catch is happening on the last updated buzzer, even if any of the earlier versions of the buzzer have errors, it'll still jump all the way down to that last catch in order to be able to handle that. This is similar to how try-catch operations work if you're used to try-catch from other languages. Okay. You can also put a .then after you've put a catch. So this could say, here's some buzzers the dot catch also returns a buzzer, so that we can say if we've like finished up our buzzering and we've finished all errors, we can see some other stuff we want to do even after all the errors occur, even finally at the end. I'm not going to run this through as a demo because it's kind of hard to demonstrate through GitHub's API because they don't actually return errors. They actually manage everything very well. But that's kind of how you can begin doing that. You can often test that you're seeing if your errors work by doing things like sending malformed URLs and sort of making sure what happens there. Okay, cool. So this is good for being able to, again, handle errors along the way. All right, so there's fetch and handling promises with .then. This tends to, in some ways, be the easiest, cleanest method. It's kind of the standard. It's kind of the way that promises were built and the way that fetch was built to be able to make that work. That said, this is a lot of callback functions, right? Like, look, it's callback function, callback function. I remember before I cleaned it up, I had these callback functions inside of other callback functions. So it can actually get a little messy and a little bit verbose. So in ES 2017, so a couple of years ago, a little while after fetch came out, JavaScript introduced another syntax to help manage this behavior. This syntax is called async await. And what async await does is it lets you write promise-based code, right? Be able to wait for these buzzers without actually having to write a callback that says, what function do I want to occur when the buzzer goes off? What I can do instead is I can use this await keyword, and I can basically say, do my work, wait for the buzzer, and then instead of having it immediately go to the next line of code, instead of writing it asynchronously, the browser, the JavaScript will actually sit and wait. It'll just freeze, waiting for that result to be done, and then once that result is finished, right, it returns and assigns it to your variable, and then you could do things like call JSON on it, right? Call, because again, you've now gotten our envelope. We can try to open up and extract the envelope. Awaits have to go inside of an async function. We mark a function as async by giving it the async keyword in front of it. So in the arrow function, you write out like this. I've already done that ahead of time for this demo. So this is now an async function, right? We just put it in front of the word function, indicating that this function is going to do some asynchronous work. It tells the browser something asynchronous is going to happen here. You might need to be busy waiting. There's going to be some awaits that occur in the middle. So again, the way this would work then is instead of using our previous fetch, we could fetch from our URL, and then I'm going to await that result, and then that's going to give me my response, right? You see how that the value that was putting inside the argument to my callback function, that's what I'm going to get back. Right, I'm going to wait for that guy, and then I can have my data that I'm getting back by taking my response and calling JSON on it while awaiting that to finish. And then in the end, I get my data. And again, we refresh, and you'll notice it all still works exactly the same. So async await is more concise to write. It's in some ways much easier to write, right? This is sort of why it's the modern method. Most people tend to use async await when they're building out asynchronous behaviors. That said, this is busy waiting, right? This means that if it takes a minute or two for the server to respond, your page will freeze. It'll just stick there. Nothing else will happen because it's sitting there waiting for that response. And usually that's okay because most of these asynchronous operations are pretty fast, but sometimes they might take a couple of seconds, right? They might take a beat, in which case like your buttons won't work, other things won't happen, like you have to literally just sit there and wait. So async await does require doing busy waiting. It does require sort of sitting there just waiting for stuff to happen, which can potentially cause a poor experience if what your operations are taking a long time. Additionally, if you want to actually manage errors with this, you have to use try catch. You'd have to add, because again, now we don't have our callbacks anymore. So you'd actually have to write your own catch error. You have to write your own try catch statements in order to make this happen, which can then of course cause some other like variable scoping issues because variables that we define inside of the try aren't exist outside the catch. And so it can make things a little bit more messy than just trying to call .catch to say, hey, if there's an error, do this. We have some other structures we have to use. So that kind of gets us where we need to go. So you're welcome to use either approach. I personally continue to use fetch then. I find it easier for thinking about fetching anyway, just because that's how I learned it. But async await can also work well for doing other kinds of asynchronous operations. All right, great. So again, we're searching our code. We're able to get our data. We're able to work with it. How do we actually let's actually get to show up on the screen before we end. So the way that we use fetch in React most commonly is if I want to submit a form and I want to say I want to get some data from a server when the user submits a form or searches for something, then we call fetch inside that function, right? I'm going to say I want to fetch this data, or in this case, I'm down here, right? I'm fetching this data. I get the data back, and now I need to display the data on the screen. Well, this data can't be used as part of rendering because remember, we've already, like this is an event handler. This is saying we've already finished rendering work. So if I want to update what data is being displayed, I have to actually update my state. So what will end up happening is I would take my state, and you'll notice that in my state data, I'm starting with my example data. And all I would do is I would take the data I've fetched and downloaded, and I would update my state to say, hey, let's now put that as the data we want to show, the data in my state, and then my component re-renders, and all of our basic interactions work the same way they had previously. So in this case, we could call our set state data, pass the data in order to assign that data to our state. So that now what's going to happen is I've got my form, right? Initially, it shows my example state because that's my example data to start out with. When I hit search, it waits a moment, and then the whole thing crashes because it's now tried to call set state. It's now tried to call that data and put it inside of my data, which means that then when I get to rendering, I take my state data and try to map it, it's crashing because we can't map on state data. State data doesn't have a map function. The way we can check this, I'm like, wait a second, what is state data? Did not update. Remember that we can debug this by console logging my state data at the beginning of my function or my component when it first renders, right? We don't want to do it after we call set. We want to do it after it gets it from the state. It refreshes that information. It re-renders the component. So I can search for, I can search for React since my request. And you'll notice the data it got back, right, is this guy. All right, that's what's coming from line 15. It's an object. And I can't call .map on objects because the data I got back from the server isn't an array, it's an object. So this is where you need to be a little bit careful with how you're managing your data, right? The data I got back from the server is actually this data object. All data objects were clear. I'm not interested in the whole data object. I don't need to know the total count. I don't need to know whether there's incomplete results. I'm actually really interested in the items, the array of objects in there. So what I actually want to do is take the items from my data and put that into my state. So I want to data objects, grab the items from that, and then put that into my state. So then once I do that and I hit search, now we're able to see my results objects data from my search in GitHub, and I can see what repositories have the word React in the title. I can search for Bootstrap, and I can see what results have Bootstrap in the title. Right, Twitter Bootstrap, there's Bootstrap. Right, I can even search for Ajax and see what results have Ajax in the title. All these different ways to make this work. Okay. So this is kind of just a note that when you're managing data, you're going to want to make sure that you're going to make sure that you've sort of structured that to match what your state is. So if your state was, data, you want your state data to be an array of objects, an array of repos, you want to make sure that anything you put into that state is that same format, because otherwise your system's going to crash. Now, we could have structured it so that our state contained an object, and then we render the items inside that object, and then we would have just put that whole object in the state to begin with. But I found it makes more sense to think about what exactly is the data I actually want to be saving, and then take what you get back from your server, pull out the parts that you need, and put that in your state in order to be used for rendering. Awesome. All right, so that's how you can do fetching from React. We're going to have I'm going to use a different video to actually indicate how we might do fetching data if we want to do it when a page first loads. Like you'll notice that when I refresh my page, it's showing my example. If I want to have it search for React initially when the page first loads, we're going to use a slightly different syntax, but I'm going to do that in another video just to break things up a little bit. Cool. That about covers how Ajax works. Again, the main things to note for this that you should really take away is that we use fetch to actually fetch from data that sends an HTTP request. And then we use this .then in order to indicate what happens to that asynchronous operation, right? Because all the response comes back later. And then, again, we convert that into an async await structure if we want to build it and write it out more synchronously.